Okay, so what we're going to do today is we're going to learn about the relay. So what is actually a relay? The definition, or rather the use of a relay is actually this. A relay is an electromagnetic switch that uses a small current to switch on or off a larger current. Now, the symbol of a relay is actually a solenoid with a switch. So the solenoid is actually, if we look inside the actual component of a relay, is actually here. So the two connections to your relay is actually these two connections here, and the two connections to your switch is actually here. So let's see what happens. This end, these 2 points of the relay, which are these 2 points, are actually connected to, let's say, your op amp. So maybe we can connect your op amp output here, all right, and then we put, let's say, a diode here. Okay, let's say we put a diode here. So what will happen is when there is a current passing through the relays, which is the solenoid, so what will happen is when it passes through this solenoid, it becomes a magnet. That means it becomes magnetized and it will attract this lever. So this lever will move in, so it will push up, and then these two contacts will close. So therefore this switch will close and this can be connected to another circuit. So which means to say we can actually connect it to, let's say, a power supply and another lamp, so that when there's a small current passing through here, the switch closes and another light will turn on. So we use a tiny current here because the current that comes out from an op amp is actually very small. So a tiny current flowing here will then cause a large current to be turned on. But if there's no current here, then the switch will open back again, because if this one is not magnetized, this lever will open and this one will move back down. So then the switch will open. So that's what it means by using a small current here to switch on and off a larger current here. Now, whenever you draw a relay, you must remember to draw two diodes. So what are the functions of these two diodes? Now, this diode is as what I explained here. That means this diode will control when your relay is turned on. For example, let's say we want to you want your relay to turn on when your op amp is positive. So therefore, when it's positive, current will now flow from here to earth. So when this diode allows the current to flow, then this relay will be turned on, then the switch will close. But when this output of the op amp is negative, then this diode here will prevent current from flowing, so the switch will open. So this diode function is actually quite simple. It allows current to flow through your relay when the output is positive, but it prevents current from flowing through your relay when the output of the op amp is negative. Now this diode has another function, and what is the function of this diode? Now let's say your output here is positive, alright, which means to say here is positive. So let's say the current is now flowing through your relay. So that means when the current flows through your relay, your solenoid becomes magnetized. That means there's a magnetic flux in your solenoid. Let's say the output of the negative switches to negative. When it switches to negative, the current will stop flowing. That means the flux here will suddenly collapse to zero. When the flux suddenly collapses, according to Faraday's law, an EMF will be induced in your solenoid. And according to Lenz's law, this induced EMF will act in a way to prevent or rather to oppose the flux change that causes it. That means the current, the induced current that flows here because of the collapse in flux will try to prevent the collapse in flux. That means it will push a current in the same original direction, because by pushing a current in the same original direction, it's trying to maintain the flux and trying to prevent it from dropping so quickly. So this sudden surge in current, if you don't have this diode, will go back to your op amp circuit and damage it, because your op amp, being a very sensitive electronic device, can only take a very tiny current. So therefore this diode will channel the induced current back to here and just travel in a loop until it dissipates harmlessly. Why would it flow through here instead of the op amp? Because when the current comes here, there are two parallel circuits, either through your op amp back to here or straight away back to here. So since this has no resistance, because an ideal diode has no resistance when it's forward biased, and then all the current will just flow here and dissipate harmlessly. So when you draw, do remember to draw these two diodes, alright, together with your relay. But if let's say you want your relay to turn on when it is negative, when the output of your op-amp is negative, then what we do is we just reverse the connection. So we connect the diode this way now. Okay, so your relay switch remains the same. Alright, and then your other diode also points the other way. So just reverse both diodes and then you'll be fine. Because now when the output is negative here, current will flow. Alright, so from 0 to your output negative, so then this relay will turn on. But the moment it turns to positive, current cannot flow because the diode is pointing up. So the sudden surge in current will now be dissipated harmlessly through your coil here.